Again,
Not yet.
Unit 6.
Not on my seat.
Unit 6, review number 2. Those of you that are watching this in other places, yes, feel sorry for me. We're going to draw some angles. A couple of things I will make mention of, even though we're going to focus in on number 2 right here. If you have a positive angle that you're working with, those go counterclockwise. And that makes a difference. When you're showing somebody an angle and you're drawing it, if you're going counterclockwise with it, you're telling the person it's a positive angle measure. If it's negative, you're going clockwise. So what does that mean? That means my axes are going to be numbered differently. So negative 130. Now here's a point where I have an advantage of doing this one, because when I break out my protractor goes all the way up to 180. I just need negative 130. So I just need to make sure that when I go to measure it, that I'm not doing the 130 up here, that'd be positive. So if I come down here to the bottom, I get lined up, and I swing around to where 130 is. Kind of hover, hang out, and draw it. Now, warning. On the unit test, when there's a question like this, I will have my protractor out. If you're off a degree or two, that's fine. If you're just winging it and you're off 10 degrees, it's going to get marked wrong. So don't try to wing it. Actually work on getting it where it needs to be as far as that goes. Okay, move up a little bit here. One positive and one negative coterminal angle. Coterminal. If I took that current degree measure and rotated it 360 degrees, a full rotation, where would I end up? Okay? So now here's the kicker with these.
Hold on.
When I'm trying to do this, if I start at negative 420 and I add 360 to it, get negative 60. Okay, that's fine. That can be my negative coterminal angle. I can put that in here. But I can't put that in for positive because it's not a positive angle. So what do you do?
300 for positive.
Yes, because you add another 360 and you end up with 300. A positive coterminal has to be positive, and the negative has to be negative. You may have to do it twice, you may only have to do it once, it depends. But you have to, no matter what, you have to make sure that you end up with one of each. All right, let's see. Find the value of the missing center angle using right triangle trig properties, okay? So we're using our SOHCAHTOA. Again, the capital letters are sine, cosine, and tangent. The little ones stand for opposite, adjacent, and hypotenuse, the sides that I actually use to calculate those. So on number 6, I am very much a proponent of labeling my sides before I start. So my hypotenuse is always opposite the right angle. My opposite is always opposite of my reference angle. And that leaves adjacent for whatever's left over. So now, I look at the sides that I have, opposite and adjacent. I notice that's going to be tangent. However,
Wait, you have that cheat sheet.
good question. What's going to be available on the unit test? There will be some basics on there like coterminal is plus minus 360. I will have SOHCAHTOA up. When we get to the special right triangles, I'll have that up. You're just going to have to be able to know how to use them. So you may be sitting here and you're like, okay, so I got this tangent. Let me get going here. Before you do anything else, be careful. Go into mode. Make sure your calculator is in degree. If it's in radian, you will not get the right answer. So, word of caution. So then let's say you're going along and you're like, okay, tangent 8 divided by 15. Harty, your calculator is broken. It says my angle is 0.009. No, the calculator is not broken. What do I have to do? What's the one extra step I need when I'm looking for an angle? second. I need that little -1 up there to get the angle. So I have to do second tangent, 8/15. Then I get an angle. And typically with angles, we go to the nearest whole degree. So that would be my answer. Okay? Only with angles do I do the second. If I do second on other things, that's not going to work out well for me. Okay? So something to ponder. All right, 8. Let me shrinketh this. All right, a basketball player is standing outside on a sunny day. He is exactly 6 feet tall. If he casts a 9.1 foot shadow, what's the angle of elevation of the sun? Make a sketch. Okay.
So what we got to do is...
So here, okay, he's 6 feet tall, so we're assuming he's standing up. That's why I'm putting the 6 over here. When you cast a shadow, the shadow is on the ground. So the 9.1 has to go where the ground would go. Okay. What is the angle of elevation of the sun? Okay. Angle of elevation will always be in the bottom corner. Okay. Will never be up here, down here. Even if this says angle of depression, it still goes here. And we'll get into that a little bit when we hit the odds a little bit later. So I'm in a situation basically like I was on the last problem we were doing. I look at my sides that I have. There's my opposite, my adjacent. Once again, I have opposite and adjacent. So once again, I'm dealing with tangent. And once again, I'm looking for an angle. Don't forget the little -1. Opposite over adjacent. And I crank this out. So let me swing this over. Second tangent with my angle measure. And again, typically we go to the nearest whole degree. So for us in this case, that would be 33. Okay. And that one gets me set. But again, with any of those, if the picture's drawn, great. If it isn't, draw one so you can see where the sides are, label things well, and you should be in good shape. Okay, let me swing down a little bit here. All right, change from radians to degrees or degrees to radians. All right, well, this is why we're going over it. If I want to go from degrees to radians,
What the heck is the drawing? Is that an airplane?
yeah, I multiply by pi over 180. And then I basically am going to multiply straight across. So when I do that, I'm going to leave pi alone. Don't put it in your calculator as 3.14 or use the button. And then what I want to do is I want to simplify this if I can. I simplify it by kind of ignoring the pi for right now. And I just try to bring the 60 over 180 down to its simplest form. We've been doing that all year. So 1/3 means this would be pi over 3. Or you could put 1 pi over 3 if you wanted to. But that's what we're dealing with here. Okay. Now if we're going from radians to degrees, I just take that fraction I'm multiplying by and I flip it over. Because then what happens when I multiply across is I end up having pi's in both places, which cancels. And 360 divided by 3 is 120, and that's my angle measure. And I'm set with that. Okay, so degrees to radians, start with pi on top. Radians to degrees, pi on the bottom, so the pi's cancel. Because that's my whole goal with that. All right.
What was the answer?
360 over 3 is 120. So then I get over to 14. We get a story problem. If the minute hand of a clock is 8 inches long, How far did the end of the minute hand travel from 8 a.m. to 11 a.m.? Use the formula S equals R theta, which is our arc length formula. Okay? How many revolutions? Okay, let's think about this. So you're looking at a clock, and you started at 8 and you went to 11. The minute hand goes all the way around. It does a full revolution every hour. So how many hours passed from 8 to 11? 3. Okay? Times 2 pi, because again, 2 pi, or 2 times 180, is 360 degrees. You're like, why didn't you just use 360 degrees then? Because when we find our angle measure, it has to be in radians for this formula to work. So we make a conversion. So 3 times 2 pi would be 6 pi, which is my angle measure, my theta. So to find the arc length then, it's just going to be my radius, 8, times my angle measure, 6 pi. And most of the time, people don't go up to someone else and say, ooh, that's 48 pi inches long, unless you want them to look at you like you're a little crazy. So what we'll do is we'll actually get this typed in. So 8 times 6. You can just use 3.14, otherwise the pi button is just second in the up arrow. So it looks like we're at about 150.8 inches, because most of the time on measurements we do to the nearest 10th degrees, we do to the nearest whole degree. But again, not complicated, just kind of getting you used to that. Hi? Very big. So, next then, we go back to our right triangle trig. Now again, to get some of you to relax, you're going to have the right triangles up, either on a sideboard or on a cheat sheet, something like that. So what I'm about to draw here, you're going to have in front of your face.
It's crazy that you got all this stuff memorized.
When you're doing these. So we had 30, 60, 90 triangles. We had 45, 45, 90 triangles. And then the sides that go along with them. So if you're ever in a trig class, this is something you need to know. So opposite my 30 is always just x. Opposite my 60 is always x squared root of 3. And my hypotenuse in a 30, 60, 90 proportionally is 2x. It's twice as big as my 30. And then 45, 45, 90 is x for both of my legs and x square root of 2 for my hypotenuse. So what I'm going to do is I'm going to use the information they give me to figure out the measures of the other sides. So here's how I normally tackle that. So, okay, we're at 16. I see they give me the 30, so I know the other one's going to be 60, and I got my 90. I normally will take a pen, if I have a different color, that's even better, and I'll write really small, bless you, what the proportions are. So for instance, opposite of 30 is my x. Okay, so this is my x. Opposite of 60 is my x square root of 3. And opposite my hypotenuse is 2x. You're like, now why'd you do that? You just put more variables all over the place. Because I'm going to go look at the side where I have a number already. Right here, because those have to be equal to each other. Cool thing this time is the problem just got really easy, because x, everywhere I see it now, just equals 4. I don't even have to do any math. So here, this is just 2 times 4, or 8. When I come down here, I plug in the 4 where the x is at. I leave everything else alone. 4 square root of 3. I'm done. Now, will they all be that easy? No. Some of them will be, though. And again, we're going to end up covering them all here over the next couple of days anyway. But write the patterns in, and then we solve for the missing side. So let's see. Okay, good. This one's going to be a little more interesting. 45, 45, 90. Okay, reminders. These sides are both x. This is x square root of 2. So this time, again, I'm like, sweet, this is kind of like 16. This is x. So if I know this side, I know this side already. That's awesome. What about here? Okay. I plug in 3 square root of 2 where the x is for this piece. The square root of 2 that's already there is still there. I got to do a little simplifying this time. So I multiply the radicals together, which would give me the square root of 4. But what's the square root of 4? 2. So 3 times 2 tells me my hypotenuse this time is going to be 6. So basically, once I know what that x value is, it's just substitution and simplifying after that. Yep. So again, I'm just kind of playing with those, getting used to this and kind of working through. And again, if this is something that you're struggling with, it's always something you can go back a little bit into the unit and either find the video or the worksheet or a review where we did some more of this stuff too to help you out with that. All right, let's see what else we got working here. Number 20. What is the measure of the missing angle? Use your trig. Let me stress that again. Use your trig. Don't try to break out the protractor. It won't work because I made sure they didn't measure out the same way. Boo, Harty. Oh, well, that's okay. So, reminders. This one is going counterclockwise, which means it's a positive angle. So I know that before I get started here. So here's my other job. We make a right triangle back to the x-axis, just like we did before when we did these. And this coordinate point actually gives me some information. Since it's a coordinate, it tells me the x and y value. Like, how's that help? Okay, here's my x-axis. My x value is 3, so I know this side's 3. My y value is -3. This is the y side of that. It comes down, okay, -3. But I'm interested in the angle. So how do I find that out? Well, here's my question. Since I'm saying use your trig, it's got to be a special right triangle. But is it a 45-45-90 or a 30-60-90? How do you know that? 'Cause you're right.
Well, there's 90.
Okay.
Okay,
she's like, well, I just happened to get it right. It was a good guess. Okay, here's your clue.
What you gotta do is,
When you're looking at the sides of your triangle, on a 45-45-90, it's just x, they're just numbers.
Okay.
If you see a square root of 3 there, okay, if you see a square root of 3, that'll be a clue it's a 30-60-90. If you don't see a square root somewhere, it's a 45-45-90. Yes?
Okay, so on a 45-45-90, aren't the two sides supposed to be the same number?
When we're looking at them, generally they would be the same, and these are, the difference is when I actually put it on a graph like this, I have to pay attention to where my axes are. So since I'm going to the right on the x-axis, my value would be 3. If I go down on the y, of course, I'm going into negative values. So if this triangle were up here, it would be 3, 3, and normal. The pattern we use is just like a guide as we're doing it. So here, it's just kind of, yeah.
So as long as it's the same amount.
Right, if it's just number value, whether it's 4 and 4, 4 and -4, it's still giving me the same clue on whether that's a 45-45-90 or not. So here's how I actually get the angle measure now. If I start working my way around, okay, there's 90, 180, I'm to 270 so far, but I still have a piece left. If I made it all the way back to the beginning, that'd be 360. So I have another 90 degrees in here. But this angle takes up 45 of it. So how much do I have left for this piece here that's not in the triangle? 45. So if this piece is 45, I have to add that to the 270 that I already have. And that's going to be my angle measure. Because what we're looking for in the end is, how far is it from the beginning around to here? How long is my curve going to be? How long is my angle? And that's what we're trying to find. And again, if you're looking and seeing, I wonder how that would apply on 19, stay tuned for the odds portion of the review at a little bit later of a time. Okay, so for now, move down a little here. Okay, 22, we're graphing. What is my amplitude on number 22? Okay, my amplitude is 3, but what does that negative do? Okay, this means typically a sine graph starts at 0, goes up, and then goes down, and then comes back up. But that negative tells me that's basically going to flip my graph. So that's one bit of information I have. What's my period going to be? 2 pi. Because my period is always 2 pi unless there's a b value change here. And in this case, there isn't one, so it keeps that the same. So I know I'm going to end at 2 pi. I know I'm going to start at 0. And now it becomes point builder mode. So like we've done before, what's in the middle of 0 and 2 pi? 1 pi. Right. Because then I just keep going by halves. What's in the middle of 0 and 1? A half is. And I keep breaking that down. Now, if I kind of like, I don't know what to do with that other one though. Close. Remember, if you start with 1/2 or pi over 2, you're just adding a half each time as you work your way down. Because 2 over 2 is just 1. 3 over 2 doesn't reduce. So I just leave it that way. And then 4 over 2 is 2 pi. And if I wanted to keep going, I could. So once I have that ready, now I'm good to go. So now when I do sine, one last question. Does sine normally start at 0 or the maximum? 0. Still does. Because multiplying 0 by a negative number isn't going to change anything. But now, instead of going up to the max like we normally do, the negative brings it down and back to the middle. And then up and back down to 0. And that would be my sine graph when I have an a value of -3. Again, it's my amplitude is still 3. That was a good catch that we didn't suck some of you in on that. But that's what that's going to look like. Okay? Got to pay attention to those little detail things because getting these values are just as important as getting the graph itself right. All right. Let's crank it up a little bit. 24. Ooh. Nice, okay? This can be rewritten, if that confuses you, as sine 1/2 x. That's what it means when I see a fraction with the x. So, first question, what's my amplitude? My amplitude is 1 because there's no number in front of my sine. So, okay, I got that part. Now, my b value is 1/2. So what's my period going to be? Because the pattern is 2 pi divided by b. 4 pi. Okay, so 4 pi at the end. Because if you divide by a half, it's the same as multiplying by 2. So now we just start doing halvesies. Half of 4 pi. 2 pi. In between 0 and 2 pi. 1 pi. And I think we can do this without breaking another pattern. 1, 2, 3, 4. Okay. Nothing else fancy on this one. All there was the period change. So just like we do normally, we start at 0 with sine. And then we go max, 0, min, 0. Okay, that is one of the things you're going to need to know when we get to the test, that sine starts at 0 and then normally goes up, 0, down, back to 0. Okay, so we're going to have a little knowledge work in here. But you guys get the mother lode question where we change everything. Fun, 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 fun. Okay, let's do this in pieces. 26. What's my amplitude? Okay, now my amplitude is 2. Normally then, I'd just write, ooh, 2, negative 2. But let's hold off on that for a minute. What's my period going to be?
It will be 5.
It'll be pi, because my b value is 2. Okay, so I got that part ready. And then what's that plus 1 on the end going to do? Okay, everything is going to shift up 1. So keeping that in mind, instead of normally, what I would normally do here, and just have it up to 2 and minus 2, since I know I'm going to be moving it another 1, I'll just add another 1 on both ends here, just to give me enough space to work with. Okay. And what we've talked about before, and I think is a good idea for most of you, is we're going to forget about the up 1 until we get the initial point set here. So let's build our line here. Between 0 and pi, half pi, or pi over 2. So then what's in between 0 and a half? Okay, pi over 4. Now, if that's something that gets you sometimes, you're like, I don't know, where'd you get that from? Remember, what we're basically doing when we keep halvesing this is dividing by 2. That's the same thing as multiplying by a half. So if you get stuck sometime, or it's a weird fraction you're dealing with, just look at that one that you're trying to find halvesies of and multiply by 1 over 2. Pi times 1 is pi. 2 times 2 is 4, and I can get it that way. And then I can go back to what I did before with my pattern. 1 over 4, 2 over 4 is a half. 3 over 4 doesn't reduce. And then 4 over 4 is 1, and I have that ready. But again, for right now, I'm going to ignore the upshift. I'm going to graph this just as like I'm ready to go right now. So I got my sign. I know I started 0. Then I go up to my max, which would be 2, because that's my amplitude. Back down to 0, back down to negative 2, and back to 0. Those are my 5 initial points. But now, I do my vertical shift, my up 1. So I take each one of those points, and I move it up 1 from where it was, and I connect those dots. And that would give me my fully shifted and stretched graph. That's as crazy as it gets, which is kind of nice about you guys having the evens right now, because you got to see the crazy one. So then we get away from graphing a little bit, even though we take some parts of it. Use the given information to write the equation of the trig function. Okay. Whether you have sine or cosine as your trig function, and I tried to help out with that here, remember, b is the number of cycles that this does in 2 pi. So when I go to write my equation here, I put in my amplitude, I got cosine. 2 pi over 3 isn't my b value. I've got to figure that out. So since my formula for figuring out a period is 2 pi over b, I've got myself a little proportion to work with. Now, if I notice right away what the b value is just by looking at it, I can do that. But if I can't or I don't, if I cross multiply, 2 times 3 is 6. And now I want to get b alone, so I divide by 2 pi, and I heard the answer out there already. My b is going to be 3. And I put that in. I've got my equation. I will not put vertical shifts on the test when we're doing these, even though it wouldn't have been a terrible thing for me to do. So if you're given the period, you have to find b is the lesson to be learned here as we're doing that. Okay, I think we're heading to the last one here. Yep, last one, last page. All right, 30. Let me put the reminder down here so we can see that. Okay, look for the number of cycles in 2 pi, because remember, to get my equation, I need to know the A and the B value. But the B is the number of cycles in 2 pi. So, A value. Ooh. Well, let me ask a different question. What type of graph is this? Is this a sine or a cosine graph? Sine. It starts at 0. Okay, so that's one thing I know. Next thing I got to take a peek at is, okay, what's my A value? What's my amplitude going to be? They may not necessarily be the same value. Okay. Normally we'd say my amplitude is 3, but which direction does the sine graph normally go to begin with? Up. This one isn't going up. So my A value has to be negative. That's the only time it will be. If it does the opposite of what it normally would do. So I got my A value is negative 3. So now I got to go through and figure out how many times this pattern does a complete cycle all the way through 2 pi. So like, okay, down, up, down. There's 1. Down, up, down. There's we're back to 0. 2. Down, up, down. There's 3. Down, up, down. And there I am to 2 pi. So I have 4. So my B value is 4. And now I've got all the information I need to make the graph. Y equals my A times the sine of B, X for my angle. Okay, now like I mentioned before, this is the evens. Odds will be forthcoming. Okay, but again, if all you do is copy everything you see and you don't reinforce it by, maybe there's a homework assignment that you didn't do in a prior homework check on something with this, or maybe there's one on the current one that you haven't done. Reinforce, because otherwise you'll just look at this, you'll kind of be like, and that would be a problem, because again, this is mucho points. So